Hey guys, welcome back to my YouTube channel. So as promised, this is a teaser for the CAPE Chemistry Unit 2 classes. There's still space, so you can join. Contact me.
Got it.
Alright, so this is what we're doing today. We're going through some stuff in Module 1. I think you know how Jeopardy is played. Don't worry about this scoreboard because this wasn't made or intended for this class, but we're going to do this anyways, right? So this was actually this was actually made for me and my friends when we were in grade 13, for the study night thing that we were going to do, which we did. We did a whole study night thing and we made it fun. So this is what I made for it. So there are 20 questions. You know how Jeopardy is played, you pick a category and the value, right? So that's what we're going to do. And you're going to do all 20 questions. So it doesn't really matter which one you choose, but make it random. You don't have to know the answers. This is just a little warm up icebreaker thing going on for us today, right? Since we're going to go back to module 1 soon. Clear?
Clear.
I don't think anyone else is coming. I think she says she's in a meeting and stuff. The meeting isn't done yet. I don't know. So if Anissa shows up, she shows up. If she doesn't, we'll just go over stuff with her, right? So pick a category, any category.
Prefix. $100.
Prefix 100. All right. All right, so this prefix is used to describe carbon compounds with 3 carbons. What is it?
I have no idea.
You're supposed to know. We went through this in the first class. But as I said, it's fine. Oh my God, I can't write. This is going to be... I forgot that I made this thing with the kiosk. Let me go back to slideshow and see if I can.
Kiosk?
When you set up your slideshow, if you browse at a kiosk, you can't click anywhere on the screen except for your coded macros.
Oh, thanks for that knowledge. Thank you very much.
Yeah, let me see if this fixes it. From the beginning, it shows 100.
Wait,
yeah,
I actually know what the answer is. It's P. Prop.
Prop. Yeah.
Prop. Yes, prop. It's actually prop. I actually know the answer. I wasn't thinking prop. Prop is the answer.
Yeah, that's true. So, or is it pro or prop? I don't think it matters. Somehow, yeah, propane.
It's prop.
Propene,
It's prop.
it's
prop.
prop. Yeah, it's prop.
It's prop. Mm-hmm.
All right, great. So if you have propane, that's an alkane, right?
That's true.
So how many what is it? Carbon to carbon, double bonds, carbon to carbon, triple bonds, carbon to carbon, what? Single bonds, what?
It's a carbon to carbon single bond.
Oh, very good. So propane structure would be C, 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 and H, 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 right? H.
Yes, because
H.
to each carbon you have a hydrogen attached to it.
Very good. So that's that. So this would be what we call the displayed or condensed. Which one would this be?
This will be the displayed formula for this molecule, propane. Mm-hmm.
Very good. You remember how to write the condensed formula?
It would basically me saying CH3, then CH2, then CH3. Is that correct?
Very good. Yes, you're correct.
Yeah, that's it.
All right, great. I don't think I taught you how to write the condensed formula for like propene.
Propene.
What would be the formula for propene? The molecular formula.
The molecular formula?
Mm-hmm.
This would be what is this one again? This is what C H C this is what CnH
2N.
Yeah, HN2N. Yeah, I was trying to remember because I mean, so that means that that means that alkane is CnH2N. No, H what? H2N plus 2, is that?
Yeah.
Yeah, so okay. So with that being, this would be C2. So that means the molecular formula would be C3 and then 2 times 3, 6, C3H6.
Very good. So if I drew the structure for propene like this, remember it needs a double bond, right?
Mm-hmm.
Then 1, 2, 3, 4, that would make the 4 hydrogen and make the 4 bonds with carbon because carbon can only make 4 bonds, right?
That's true.
You'd add a H.
I
Should I put
put
another H on this carbon?
no, you can't put another H over there. So
Very good.
no,
And
you
how
can't. You can, oh, this can only take one H in the middle. This now you have to put the other H's on it because all these will be taken up.
many H's would
It's sharing one bond already with carbon, and it's sharing 2 bonds with carbon on the on the right, so it only has space for 1 hydrogen atom.
All right. So what would be the how many hydrogens would go on that carbon?
On the first carbon to the what left?
From the left, yeah.
Hmm?
Yeah,
3 hydrogen atoms.
very good. So this would be your displayed formula, right?
You know, I never thought about this before. I've never thought about this before.
You want to take a crack at the condensed formula?
I crack out the condensed formula. All right. I know for the first one it would be CH3. That's how I would start it.
Yeah. What would you put
How would
next?
I write? How would I write something for like this now? I'm trying to go into my memory to find if I ever did anything with a double bond, like had to learn the like looked at the thing how it was written for a double bond or something.
You can ask me any question, you know. Ask me a question that would help you to answer the question.
All right.
That's always an
Question.
option. That's just not an
All
option on
right.
your exam, but it's an option here.
That's true. All right. How do I ask a question? How could that could help me?
I don't know. What's in your head? What do you want to know? Except how would you write this? That's not a great question.
That's not how that's not the whole question is all right out of it. All right, now. All right, can we show a double bond within a condensed can we show a double bond in a condensed formula for something?
Supposed to.
You're supposed to can do it.
You're supposed to do it, not can do it. You're supposed to do it.
You're supposed to do it, so it's possible. I don't know what continue with the class. I don't know how I would give you a question for it, honestly.
I just answered the question. I just answered the question. So you're supposed to figure out something now. It's nothing hard. It's just how you wrote the condensed formula for this. You're just going to put the double bond in it.
Alright. For the condensed formula first, this said the CH, this CH3, CH2, CH3. That's everything single. Alright. I can put C. Alright. Can I put C that the and two dashes?
You put the CH, then the double bond, then what?
Oh, so you're right. Oh, then you can put back CH2.
Yeah, because remember you're trying to tell us what is attached to each carbon. So to this carbon here, we have 3 hydrogens and another carbon atom, and then we'll have one hydrogen and 2 double bonds. And then attached to that carbon as well, you have another carbon, right? And 2 hydrogens is attached to this carbon atom here. Seeing that?
Okay. I'm seeing that. So if we were able to show single bonds, we just simply say CH3 and one single dash. But because we don't write it, so it would only apply to stuff with double and triple bonds, right?
Exactly. So
okay, cool.
let's try with propyne, PROPYNE. Is that
Propane?
possible? No, the alkyne. What would be the formula?
The
This look weird.
alkyne?
I've never, probably because I don't work with alkynes or I've never worked with them, but it's look weird. Um, what's the general formula for alkynes?
Oh, CnH2n plus 2, that.
-2. Remember, alkanes are the +2.
Oh, I wonder what the hell this is. I wonder if I'm from the alkanes that what I mean I mix up with some. So this one, this is which one now? In? Say it again. This one, what is functional for this one?
Alkynes.
Alkynes, alkynes,
These are the ones
alkynes.
with the triple bonds. Carbon to carbon, triple
Okay,
bond.
alkynes. Oh yeah, I don't know these ones very much. That's why I don't work with them often.
So what would be the alkyne form of proof? What would be the formula?
The
C3H what?
the molecular formula
Mm-hmm.
C3H6 no H4.
All right, let's try. So let's put a triple bond, C, single bond, C,
Triple,
one, two, three,
triple.
four. Tell me where the hydrogens would go.
You would put the hydrogen start on the second carb. You have space for that? No? Okay, then we may put it. Three them may take up. Let me see. It share one bond with this already, so all three that take up. Just share three bond with this. Alright. Put it on the second carbon.
The second carbon?
The second carbon.
You sure?
No, allow me to tell you. You have to go up on the first carbon.
First carbon, okay.
Mm-hmm.
Any more on the
and then
first?
on the last, and then on the last, no, you can't put any more on the first carbon there. So on the last carbon now, which should be to the right, you'll put 3 hydrogen atoms on it.
Very good. Okay. Oh my god, I can't write on top of this. I forgot.
And you can't write on the black something.
No. Because I know why. I know why.
Like,
It's it's a part of the layout of the PowerPoint itself, so I can't write on it. Because if I click it, let me show you. If I click it, see, the point goes up by 100.
You forgot to teach me something here.
I don't even remember if I remember. I don't even know if I remember how to do these things. Yeah, I remember. No worry. Yeah, I can do it.
Yeah,
It's just been a while.
If we cover the PowerPoint, you might show me how this go.
What?
But yes, back to the lesson. But how this layout something going why the whole reason why you can write on it on the layout thing. You can write on the silver box something, the silver square something, the gold square something, even though it's a part of the layout. But on the black thing you can't write on it even though it's on the layout. So I want to know the difference between those stuff, and I want to know how you can make numbers go up on this stuff.
I actually wrote a code for this, for the numbers. It's called a macro. And
so you
I can write, but it's just that whatever I'm writing will be behind it because of the layout that I did.
Oh, layout. So it has to do with two things, layout and the macro. I can go research on how to do the macro coding thingy, but I wouldn't like how you get the layout like that.
I changed the view. I went into slide master view and changed it.
Okay, thank you. So slide master view, and I would need to learn how to code for the macro thing. Okay. Thank you.
Yeah, no problem. All right, tell me the condensed formula for this alkyne here.
The condensed formula now. So you showed me I told you the molecular formula. We did the display formula, so now we have to do the condensed one. Okay. So now it's going to be CH. CH, yeah, you're going to start out with CH. You're going to have 3 slashes, so to indicate the triple bond. You're going to have C, and you're going to have another C, a CH3.
Very good. All right, so I'm thinking we're good
This
to
look
go.
weird though.
Yeah, it does. I think it's because we don't usually do it. All right, choose another one.
Okay, we're going to be doing we're gonna be doing perfect. No, no, we're gonna do FG and HS. What do you say FG and HS stands for?
Functional group and
Functional group and
homologous
homologous
series.
series.
Yeah.
The homologous series means alkane, alkene, the other one,
Yep.
the other one, triple bond, and the alcohol one. And then
Yep.
the functional group is like the single, the triple bond, and the double bond. Not true. And when I have one OH group or not true.
Yeah, so homologous series would be like carboxylic acids, while the functional group for that would be the COOH group or the carboxyl group.
Okay, thank you. We're going to go to FG and HS 100.
All right, 100. You're keeping it cheap. That's fine.
To me.
All right, so this homologous series has compounds with C to C single bonds. Name it.
Alkane.
Yeah, that's good. That one was easy. All right, next one.
Did it move? Oh, it just moved. We're going to be going to name the compound $200.
Okay.
Remember me? $200.
How you can do this? You can, first of all,
Mm-hmm.
you can see that there are only carbons in it, right?
Name the compound. Jason, why am I thinking about this again?
Miss, answer the question. You're seeing that there are only carbons, right? Carbon,
No,
carbon.
there are carbohydrate and hydrogen atoms in this compound.
Yeah, not taking into consideration, not considering the hydrogens right now. You don't.
Okay.
So I want you to pick up what the homologous series would be or the functional group.
Okay.
What type of compound would this be?
This is what we have. What 1, 2, 3, 4, 5, 6, 7. We have 7 carbons in this compound, right? 7. That's our sept. No.
And there are
What?
no. Hello, Miss.
Mhm.
You get carried away too easily,
Alkane.
no? Focus,
Alkane.
focus.
It's alkane. It's alkane. It's alkane
Very
because
good.
there's no singleness, no OH group or nothing in this.
Very
Nothing
good. So
at
it's an
all.
alkane. We established that. Now, what I would
Yes.
encourage you doing whenever you're doing a question like this, because it's very easy to get mixed up, is to draw out the displayed formula because you're more familiar with the displayed formula, right?
Yeah.
So tell me how would you describe to me how you do the displayed formula for this?
We're gonna like write out 7 carbons like all in a row there. So no, it's this like one chain. This have chain in it.
A branch.
A branch. Wait.
Which one would be the branch?
The 5th
I'm not saying
carbon
you're
is
wrong.
branch.
I'm not saying you're wrong, and I'm not saying you're right. Which one would be the branch?
The 5th carbon.
Okay, this one.
No. Where there? Oh yeah, that's the one.
Okay.
That's the one that I'm assuming will have the branch.
All right, so we have a 6 carbon chain. That's what you're saying to me?
Yeah, 6 carbon chain, because then you have to break off something.
And we have we have a chain, a branch, you say, here on this carbon here. Okay, no problem. Then the rest of these are what? Hydrogens?
Yeah, the rest of those are the hydrogen atoms.
All right. You want to take a go at naming this for me?
Let me name it.
Name the compound.
Oh, you mean giving? I'm not remembering the prefix for 7. I remember meth.
This isn't a 7. It's not 7. The longest chain isn't 7 carbons
6.
long.
Hex.
Right.
It's hex. It would be something hex. Hex something hex. Hexane.
You sure it's hexane?
No,
Remember,
it's not.
we have a
No,
branch.
you have a branch and I remember what you call it. But the branch no, that it'll be called, it'll be on, because it's on the what no? 1, 2, 3, 4. If 4 will come in somewhere, we just remember how it go. Exactly. How this go?
Give me a sec. My phone is dying.
Okay. Capture the storm. Yes,
All right, sorry about that. The thing is, I couldn't let my phone die because I'm using it to hotspot my laptop.
okay, cool.
All right, what did you say?
I'm reviewing how to name the branch thing for it.
All right. You have any questions for me?
The question I'm gonna ask you how remind me how we name stuff with the branch stuff. That would be the
All
question,
right.
but you answer.
You
Oh, you're
use
going
the
to answer it.
number. You have to tell the location of the branch first of all. So the branch is either on the 4th or the 3rd, right? And remember, I told you that you use the smaller number, right?
Yeah.
So
So in this case, it would be, oh, it would be the third one in this case, cause yeah, I should start from the back. So I
very
have to
good.
put down 3.
All right. So 3 dash. You identify the branch. Next, this is what type of group? Methyl, ethyl, propyl, what?
Methyl.
Methyl, very good. So we put 3 methyl. Let me hide this because it's in the way. So 3, my God, 3 methyl.
How would the ethyl one look?
2 carbons, H, R group, H.
You're drawing on
H.
you're drawing on the thing now. Okay, I just seen it. Something looks so.
Yeah, I'll show you some more. I'll show you one soon. But yeah.
Oh, I remember I asking these questions in one of the first sessions, and you said the one that is most commonly seen is the methyl group.
Yeah, in your syllabus.
Okay.
So
Let's
then
wondering the other ones. Yeah, 3 methyl
hexane, because you said it's an
hexane.
alkane. Yeah, and it's 6 carbon. The longest chain is 6 carbons long. 1, 2, 3, 4, 5, and 6. Seeing that?
Yes, I'm seeing that.
All right. So all this is clear, right?
Yes, it's clear. Thank you.
Yeah, man, no problem. All right, choose another
So
category.
let me go over it. So first, when I'm giving the display the formula for what's that word, for a branch alkane, I'm going to draw out the thing. I'm going, if they give me the condensed form, no, I condensed formula. They give me the condensed formula. When they give me the condensed formula, I'm supposed to draw out the display formula from it. I'm going to write it out, and then now I'm going to look at it, and I'm going to say which of the carbons will have the branch on it, and that will be indicated by the bracket, because they would use the bracket thing. So that's how I would know that's how it go. And then now what am I going to be doing afterwards? Afterwards, I'm going to be looking at a different type of group would be on it. It can be methyl or ethyl or something else. And then now I start naming the compound. So I would identify the chain by saying which would have the shortest chain. So I would say then no, I would indicate which one of them have the shortest chain. And then no, when I would look at that chain, I would look at whether it's a ethyl or methyl or something group. And then no, lastly I would put the name of the whole compound, and the whole name of the compound is determine how long this chain is. So right?
Yeah.
Okay.
So
All
that's
right.
cool. So you got
Let's
that
go to
right.
mm-hmm. Let's go to explain it $100.
All right.
Nothing exciting about this life.
All right. So explain combustion of an alkane. Mention the products of both complete and incomplete combustion. Oh my God. We didn't go
No
through
need
this,
some.
but
No.
you should know what combustion is.
Combustion is the burning of something using oxygen.
Yeah.
No, that's the most basic. That's the basic definition I know. It's where you burn a compound in the presence of oxygen,
Yeah.
and
You
you're going to get the products. You're going to get the products oxygen, hydrogen, and something else. Remember,
sure
I
it's
don't remember
hydrogen
the
and
third.
something else?
Yes, it's hydrogen. Yes, it would be hydrogen and something else. I
All
don't remember
right.
what the other thing should be. I don't know what the other product should be. I don't remember what the other product should be at this moment
All
in
right.
time.
So if it's hydrogen and something else. All right, let me do this. So let's say our alkane is CXHY, right?
And carbon dioxide? No?
Yeah, it's carbon dioxide. Okay, you have to get, so the
Yeah.
carbon has to go somewhere. So you
Yeah.
get O2 molecules and that burns to form CO2. And you sure
Mm-hmm.
it's hydrogen? I'm asking you that again. You sure it's hydrogen?
Wait. Let me check my answer. Yes, I have hydrogen. You have to put it, you have to put the hydrogen go somewhere. It has to be something. It has to be
Yeah, it's
hydrogen.
water though.
Water, oh, in the presence of water. How is this possible? Let me see. How is this possible? Yes, it will be possible because they don't have more than one hydrogen in the thing. Yeah. So at the end, it would add up back to it. True, makes sense. Water.
And if you had a CH, say N in your something there, in your compound and you burn that in oxygen, you would get carbon
I would get
dioxide,
nitrogen gas. I would get nitrogen gas.
nitrogen, nitrogen dioxide, I think.
Nitrogen
Yeah.
dioxide?
Yeah. Or
Oh,
nitrogen. Yeah.
oh, oh. Okay, cool, cool. I'm learning something. So it wouldn't be something by itself. Basically, it would be attached to oxygen. Okay,
Yeah,
cool.
that's true. And if it were sulfur, it would be sulfur dioxide.
SO2.
Yeah.
Sulfur dioxide, yeah. Two. You get the answer because of that, yeah. I only water, I know, like dihydrogen. You can call water dihydrogen oxide.
Yeah.
Okay, just call it that. Remember the formula name for it.
My God. All right. So this would be the products of complete combustion. In the case of incomplete combustion of an alkane, you wouldn't get carbon dioxide, but carbon monoxide. So the complete thing would look like this.
Mm-hmm.
CXHY. Of course, you'd be given an alkene, all right? O2.
Uh-huh.
Wow. This sound deep a while
So
ago.
let us do it. Let. Oh yeah. Me don't want to give me one alkene, like one actual alkene.
Yeah, I'll do that. I'm just giving you the general thing first.
Okay. General thing, it would be CXHY plus O2
Mm-hmm.
to give you carbon monoxide, which is CO plus H2O. That incomplete combustion.
Yeah.
Interessante.
What will be the chemical equation, complete chemical equation for the complete combustion of propane?
Propane.
Yep.
So wait. Let me write it down before I tell the nonsense, okay?
That's fine with me.
The formula would be what? our 3, I will have the n plus 2. Go 2n, so that'll be 12. So 3 times it must be balanced on all the fancy stuff there.
Yes, ma'am.
Come on, we can give it and balance it and then I give it the balance thing with what once you on screen.
Yeah, that's
Is that an
fine.
option? Okay.
Yeah.
So the unbalanced thing is what? C3H8 plus O2. Yeah, that yields carbon dioxide, so CO2 plus H2O.
Is it balanced?
No, no, it's not balanced. What's the advice when they said to balance these things? They said don't try to balance oxygen first. Balance everything else first. That's what they
Balance the
said, right?
bigger stuff first. Yeah.
Alright, let's just try to balance hydrogen because that's bigger. We have 8 on this side, so how much we need on the side? We're gonna need 4. So we need 4. So that now we have one balance up now. So now we have if we try to balance the follow right there. If we try to balance carbon now, carbon have 3 on the side and 2 on the side there. Something. So now it's not gonna be this hydrogen and carbon balance. So 4 times 2 is 8. 8. So no, yeah. So it's our 4 plus 4. 4 plus 4. 4 plus 4 is 8. So you say this balance now. I would have what? I would have 8 carbons. I would have 8 oxygens over here. Then I would have what? Plus that 4. So 2, 4 plus 4. So the balance thing should be what? There should be a 4 in front of O2 on the reactant side, and there should be a 2 in front of carbon dioxide on the product side, and a 4 in front of
Two.
water.
At two. At two in front of carbon.
Yeah, 2. Thus 2.
But there are 3 carbons over there.
So
You have
if
3
we put
carbons over here.
I mean, I have 1 carbon over here. So say me put 1 2 in front of carbon, wouldn't it become? Oh, Mr. Yes, me give you the wrong idea. Sorry. Sorry. Let me rebalance it over. I'm sorry. 1 3. So it should be 3. So it should be what 3. So then it should be what 6 plus 4. Plus 4. 10. Yes. Let me check it now. Check something now. I know have 10. I know have 10 on this side. I have 10 active on this side. How much we have already? We have 6. So yes. Yeah. So now it should be sorry. It should be a 10. There should be a 10 in front of O2 on the reactant side. A 3 in front of CO2 and like a 4 in front of H2O.
Very good. Great. So that's balanced. So that's clear with you, right?
I get how to balance it and everything, and I see and I understand the complete combustion and the incomplete combustion thingy. Right.
All right. So let's go to another one. Next, choose.
You know, come up yet. It still come up, I think.
Whenever it comes up.
All right, prefix $300.
Prefix 300, all right? All right, what prefix would be used to describe or define this alkyl group shown in the condensed formula?
1, 2, 3, 4, 5, 6. Hex.
Yeah, hex is great because this here is a branch, right?
This one, no. It would be a methyl or an ethyl something.
What do you think?
Come and dry out. Come and dry out. Come and dry out and see. Come and dry out, please.
Sure, I can draw it out. All right, so carbon, carbon, carbon. We have a fourth carbon on that. You have carbon, carbon, H, 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 carbon, carbon, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, whichever way you go. Yeah, so hydrogen, 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 hydrogen. What do you think now that you're seeing the entire thing drawn out?
Name it for you now.
Yeah, you can name the compound, but first of
me
all, tell me what the group here is, the branch.
the group, as in what you mean? The ethyl, you just show me. Oh, the ethyl thingy.
All right,
This is ethyl.
so we established that that's ethyl.
You have two of them. You say I know about methyl, ethyl. You have more?
Yeah, 3 would be propyl, but I don't think they're going to be such a big
You're really
one.
low. Could you repeat, please?
I'm saying that 3 carbons down would be propyl, 4th would be butyl, butyl, right? 5 pentyl. Yeah, but those would only come, you'd see those in very long compounds, and I don't think they're going to give you that long, but if you see it, you'll know it. Don't worry about it.
Okay.
If you use the same basic principles that I've been telling you, then you'll be fine. So name this compound for me.
This would be, so first I have to start on the shortest chain. The shortest chain would be 3, so 3. Next, I need to tell you the name of the group, so I need to tell you 3 ethyl, and I need to tell you the whole long chain actually is, and that occurring is hexane, so it's 3 ethyl hexane.
Very good. All right, so you got that one. Choose another one, anyone.
It just came up. Let's go to explain it. $400.
400?
Yes. Don't tell me to sit here, but alright. Explain it $400. See? Maybe I be too brave tonight. That's a problem.
All right, so explain how carbon compounds are able to make single, double, and triple bonds.
Because of tetravalency, basically. Like, how do I explain that in a way? I know it's because of the tetravalency, so they basically have what? They have 4 valence electrons, and this gives them the opportunity to be.
How is it that carbon has 4 valence electrons? Because if you draw it out and think, if you draw the iron box method, it wouldn't show that it has 4.
Okay, alright, I know I'm supposed to explain this now using the theory of hybridization. That's how I'm supposed to explain it now.
Yeah. By the way, I'm not going to cut this video tonight. I'm going to post the entire class, alright?
Yeah, hear me a chat.
They always I hear you a chat. I don't edit you out. I told you that.
Yes. Anyways, yes. I don't remember the theory of hybridization that well, honestly. Could you review it, please?
Of course, no problem.
Thank you.
All right, so the basis or the principle It basically comes on the basis of Hund's rule and off-Ball's principle, right? I hope you
Yeah.
remember these. So you have the 1s,
Yeah, 100 and off-bar free.
the 2s, and the p. Where you're going to have the px, the py, and the pz, right?
That's true.
All right. So let me just draw in these first. So carbon would be 1 up, 1 down. That's 2 electrons, 1 up, 1 down. That's 4 electrons. 5 and 6, right? So that's the arrow and box method shown there. Now, based on
Yes.
off-Ball's principle, we have to fill the lowest energy levels first before we can pair them, right? And what does Hund's rule say? You remember that one?
Wait, if above principle say we have to fill it from lowest, so from lowest to highest, that means that we always have to fill 1s first, then we have to fill 2s first before we can even continue. No, Hans principle are the one with the half spin something rule. Are him that?
You sure that's not Pauli? The exclusion principle?
That's Pauli's exclusion principle. That means to say, Hans principle I want with the 2 arrows something like each box can only hold 2 arrows, which would represent the electrons.
I'm sorry, I didn't hear that.
Alright, I'm saying that if our principle states that you have to fill the lowest energy levels first, meaning you have to fill 1s first, then you can, after you fill 1s, you can go fill 2s, and you can go fill like 3p and all in something there. You get me, answer, right? The different quantum levels, right? No, Pauli's exclusion principle would be the thing with the half spin. So I'm saying that Hans principle must be the one with the arrow thing where each box can only hold 2 arrows, which would, I mean, say arrows mean electrons, basically.
Yeah, so Hund's rule basically states that you have to fill every energy level singly first before you can pair them. So that's why this box here has the availability to accommodate 2 electrons, but you can't drop 2 electrons in there, right?
You can't do that.
And then you'd need an electron from this atom here, this carbon atom in this one before it can get paired as well, right? So it's not like you can use off-Ball's principle and use another carbon atom's electrons and put it in this box, then pair them, right? That wouldn't work.
That would make no sense. That would make sense based on the principle that we used to fill the around box method. That won't work. Those principles, because that just wouldn't work. That's just foolishness.
All right, great. So for carbon-carbon single bonds, we have sp3 hybrids, right? Where you can see that you would have 4 hybrid orbitals because you'd have 1 s orbital and 3 p's, right? So that gives you a total of 4 hybridized orbitals. You can see that, right?
Come again?
All right. You have sp3 in carbon-carbon single bonds. Carbon is able to make 4 bonds, right?
Yeah, you have SP. Remember, say you have SP2 and you have SP3. That's what you're referring to? I know.
Let me ask you one simple question. Let me ask you one question. Focus on the question that I'm asking you now. With carbon-carbon single bonds, each carbon is able to make 4 bonds, correct?
Yes, because it's tetravalence, yeah.
Okay.
Because tetravalency, yeah. So
With carbon-carbon double bonds, how many? You would still have the ability to make 4 bonds, but there's a difference, and I'll show you. No.
Okay.
1. All right. Let's look at this. All right, one of these bonds is a sigma bond and one is a pi bond, right? From the double bond here.
Yeah.
1 sigma, 1 pi. What that means is, pi bonds are formed by, or pi bonds formed?
Pi bonds form when we have like double or triple bonds.
All right, not the question, but that's fine. pi bonds are
Yeah,
formed by the
I don't know
electron.
how they're formed. I just know when they're formed. I know when they're going to pop up.
No, you know how they're formed. They learned that in Unit 1 and we stressed that last year. You know how they're formed. Pi bonds are formed by the lateral overlapping or the sideway overlapping of two pi orbitals. P orbitals, sorry. Remember that?
I know why I keep forgetting this because I'm not relating it to the carbon structure. That's I'm out of the it.
Okay, that's fine. So yeah.
But
So one of
I remember you definitely saying it's for true.
yeah. So one of these is a pi bond, one is a sigma bond. Remember I told you that sigma bonds are formed by hybridized orbitals, right? While pi bonds are formed by the unhybridized orbitals. And I'll show you that no. Now in the case of this here, this carbon to carbon single bonds would have his sp3 hybrids. I'm tired. sp3 hybrids, right?
Yeah.
This would be a total of 4 orbitals because 1s and 3 p's, right?
Mm-hmm.
So you would end up with 4 sp3 hybrid orbitals, right? Hello?
Yeah. While you speak, I'm listening. I like me I follow along too.
You're
So
following?
I'm still here with you. I'm just in the process of digesting what you're saying and then applying it and
You're
seeing what you're
following,
saying.
right?
Like yeah, I'm following it so far.
You're
You're
understanding
basically
how we got 4 hybrid orbitals?
yeah, I think so. What's going to happen is that the electrons in the 2s orbital, those are going to move. They're going to move up, and the ones in the they call that the 2p orbital, them all come down, and they're basically going to be like a merging of these orbitals that are going to. Yeah, described them using a word last class, but they're going to have equal energy. But yeah,
Degenerates.
they're going to have equal energy.
Degenerates.
They're going to form degenerate orbitals. So
Yeah.
that's how you came up with the 3sp. The 3sp orbital is going to be between the 2s orbital and the 2p orbital because it's basically a merging of those two orbitals.
You understand how we got
Basically,
4 hybrid orbitals from sp3?
four orbital. If I understand it, let me see if I understand it.
Yeah, that's what I've been saying. You have 4 hybridized orbitals here.
Mm-hmm.
And you have 4 sp3 hybrid orbitals. Are you seeing how we got the 4 sp3 specifically?
No. Mm-mm.
As I was saying, 1s, this is literally telling you that 1s orbital mixed with 3p
Come here, my sister.
orbitals.
Come here. I'm sorry. My sister wants to say something to me. I'm sorry. Give me a second.
All right, no problem.
Saying no, I'm sorry.
All right, I was saying that whenever we're talking about hybrid orbitals, we're talking about the mixing of orbitals, right?
Mm-hmm.
sp3 here literally means 1s orbital mixes with 3p orbitals, right?
Uh-huh.
So 1 plus 3 is equal to 4. Clear?
So the 3p, the sp3, sorry, the sp3 orbital means that one one s orbital. No, I don't know one s orbital.
Yes, it's 1s orbital, not the 1s orbital, I know.
It's one two s orbital.
Yeah,
It's a one two
one,
s
two,
orbital mixing with huh?
yeah, this 2s orbital here mixing with the
Mm.
2p orbitals over here. Let me hide
The
this.
with
Here,
three
there
with
are three
the
2p
two p.
orbitals, the px, the py, and the pz, right?
Mm-hmm.
This s orbital, the 2s orbital here mixes with the 2p orbitals here, right?
Mm-hmm.
And that would give you 1, 2, 3, 4. sp3
I can
hybrid.
annotate. I can annotate on your board. I can annotate on your board.
Yeah, you can annotate on my board.
Let me do that. Let me do that. So what's happening is this, right? What's happening is this. I probably shouldn't have chosen to do it yet. I'm very crying. I'm very sorry about that. What's happening is this. Let me see. This is what is in my head. We can't write my board in and he told me right. There's something here. It's so disgusting.
It's fine, it's fine, it's fine. I think I'm understanding.
You get what me I say so far?
Why I draw one next one above. Okay, I think I get it. Yes. Yeah. So the 2s would have lower energy than the 2p's, the 2p's.
And then we're gonna have something like this up here so then.
When they mix, Owen, when they mix, you're going to still need, when it mixes, what you're going to have is the promotion of one electron from this 2s into this available 2 space, right? So now you'll have a total. Now you'll have a total of 4 orbitals that have single electrons.
Clear? Do you have space, right? Clear?
No, it's fine.
Okay.
You're going to have to clear it eventually when we're doing another question.
Clear. Let me clear. No. Is it
So
gone?
as I was saying, from this 2s orbital here, you'll have the promotion of one electron into the space here that we had originally had empty, right? So now this would be a 2s orbital. Wait, let me not say a 2s orbital because I don't want to confuse you. When these mix, you'll have one s orbital, just put down s, and then because we mix the 3 p orbitals, right? We're going to have p3 hybrids, right?
So I basically like said this the little let me see something. Yeah, see my mouse? Or no?
No, I'm not.
Not. Why didn't there something here? Alright, let me just type. Let me just write this. So I basically I'll come so annotate something give me something. So I basically like so then two something here mixed then. Then mixed up. I just
Okay, yeah, I'm seeing it now. Yeah, those two, the 2s and the 2p orbitals mix. That's all that happened.
I just say instead of 2s orbital having two arrows in them this time, it's only going to have one. And that going to happen? Okay.
So that's why we have sp3 hybrids, because we mix them. So you're going to get, as I was saying, this sp3 notation literally means one s orbital, this one s orbital mixed with these 3 p orbitals. That's why we say sp3.
Okay.
That's clear now?
I think I get it now. Yeah, I think I get it now, yeah.
All right. And because we have a total of 4 orbitals mixing, right?
Yeah.
That's how we got the 4 hybrids. That's clear now?
That's clear, yeah.
And because I said hybrid orbital or hybridized orbitals form sigma bonds, we have 4 sigma bonds in carbon-carbon single bonds. You seeing that?
I'm sorry. Go back over. I'm sorry. Somebody just gave me something. My sister gave me something, so I was distracted for a moment. Sorry. Could you go back? Could you,
All right.
The sigma thingy, yeah.
So I said sigma bonds are formed from carbon, the hybridized orbitals, right? So here in carbon-carbon single bonds, we have 4 sigma bonds being formed, right? and we have 4 hybridized orbitals. You seeing that?
Yes, I'm seeing that.
So in carbon-carbon single bonds, we will have one sigma bond here, one sigma bond being formed with this other hybrid orbital, another sigma bond being formed with this hybrid orbital, and another sigma bond being formed with this hybrid orbital. Seeing that?
Mm-hmm.
No, with carbon-carbon double bonds in the case of alkenes, remember I said you have one sigma bond here and a pi bond here, right? One of the bonds is a sigma bond, one is a what you call it now, pi bond. Carbon-carbon double bonds, we have sp2 hybrids. Give me a second, my house phone is ringing.
Okay.
All right, I'm here. I'm back. Are you here? I'm sorry about that. Hello?
Yeah, I'm here. I'm here.
Okay. I think we might have to stop soon because we've been at this for a longer time. We've been here for over 2 hours.
Okay, so we can stop. No, we can stop now or
Let
finish this question.
me finish this, man. Let me finish this and do a couple more and then we stop because you're probably tired. I know I'm tired.
No, we can do a couple more. We can't. We're my lab.
Oh, and we have that figured out. Oh my God.
We can do a couple more.
All right. sp2 hybrids would be in carbon-carbon double bonds. sp2 hybrids would yield how many hybridized orbitals in all?
3 hybridized orbitals in all.
Very good. So that would total a total of 3 sigma bonds, and seeing that carbon can make 4 bonds, the other bond that is left would be a pi bond because we'd have a free
pi
pi
bond
orbital for another pi orbital to overlap with, right? In the carbon bond, in the carbon, right?
That's true. Yeah, that's correct.
No, in carbon-carbon triple bonds, this would be
We're going to get sp, yeah.
Just sp hybrid orbitals, right?
Just sp, yeah.
This is a total of how many hybrid orbitals?
2 hybridized orbitals in total.
Very good. So how many pi bonds and how many sigma bonds?
We have 2 sigma bonds and we have 2 pi bonds.
Very good. So that's clear to you, right?
I see something I didn't see before. Well, Mr. Something go if Mr. Post explain it again, that help me explain it.
Okay,
And
great.
just in
Yeah, continue.
Just to sum up, when I get asked a question like this, I would first explain why the Aronbach method wouldn't be able to explain this, and then I would explain it.
You can. Yeah, you can. Like no one's stopping you. Like explain what you know, right? As long as it is relevant to the question, it's fine.
But remember saying like mark enough mark enough things from me, like me have a tendency like write and chat and question.
You never
Right?
say me not like mark enough things from you. Me not like mark enough unnecessary things. You have a tendency to fluff.
I mean like I have a tendency to fluff and say irrelevant stuff. You're totally irrelevant, but to the question in a really relevant to answering it.
Like I'll ask you why things in free fall at 9.8 meters per second squared, and you will tell me about Millikan's experiment. Yeah. I don't have a problem if what you're telling me is relevant to the question. I have a problem when you're telling me things when I have nothing to do with the question.
So that's all right. That's
As I said, you personally, or when you have a tendency to get distracted by your own self. So I'm telling you to stay focused on what you're talking about. And you do it a lot. Even now in classes, you'll be talking to me and probably ice cream pop up in your head or in your sentence and you start talking about the ice cream truck.
Yes,
Yeah, so
I need
that's
to
just
stop
how
it. I
you
need to
are.
stop it. I need to
So
stop
I'm
it.
just
I,
telling
I
you
need
to be aware of that.
I need to change. I need to change. I need to change that about myself. I need to stop it. I'm going to stop it. But
Oh my
anyways,
God.
back to
All right,
original question.
let's.
Is me answer is me saying this and that, like the Arabic method and explaining Albach principle and Hans rule relevant to this question, or we can just go straight into hybridization.
You could just go straight into hybridization, but if you're going to mention Hans rule and Aufbau's principle, I wouldn't say give me a whole history of Aufbau and Hans. Just tell me what the relevance to the question is, right?
Mm-hmm.
Which is probably a one sentence. You don't have to go over one sentence and then explain hybridization to me, because that's
All right.
that's the meat of the answer.
That means that simply means I'm just going to go straight into hybridization, because me know myself, I'm not answer the question in a one sentence. Probably I'm getting a three sentences.
Okay, so stick to just going into hybridization then.
Yeah.
So that's how you'd approach answering a question like this. That's fine?
That's fine.
All
Are
right.
you going to record going to the lab or no?
No. The lab is for you. So I can't
Alright.
believe. Hey. All right. Let's do a few more and then
No,
go into
sir,
that lab.
girl. No. Come, go to the lab. You're tired. No. Come.
Finish up the prefixes. And the next class we'll finish this after we do I think we're doing titration next week, right? That's what we agreed on. Hello?
Wait, 1 second. Give me a second. Please, my laptop is dying. Give me a second.
Oh my God.
Alright. My laptop is plugged in now. Alright. Question.
Back titration for next week, right?
Please, I have some questions. So we're doing that next week. I would read up on the theory part and then just come out and we'll just do the practical part, which will be explaining questions. That's okay
So
with
you
you?
want to yeah, that's fine with me. That's fine with me. If you don't want me to teach you the theory part, that's fine.
No, if we take up the time and all that, me no know it'll affect you like
Yeah,
that,
I would prefer you do some prior reading so I can just do an overview and then we jump into practice questions. That's way
So
easier and it saves a lot of time.
I do my prior reading, I'll come, do prior reading, do an overview, then do the practical part. The questions I'm
Yeah,
prepared,
and the
they're on the
questions.
document. I think it's like 4 to 6 questions on the document.
All right, that's fine. And for the gravimetric analysis questions that I have left, I'm going to upload that as an assignment for you to complete that and submit it, and I'll mark it online.
Yeah. Cool.
All right. I have to give the rest of the girls. Or the kids, right? I have to give them the rundown of what we did today and the assignments and things. So I'll have that to do as well. Because they missed it, I'll probably just do a makeup session. I don't know yet. But let's complete the prefixes.
Oh yeah, when I complete the perfect, we're going to come back to this PowerPoint and finish it like the week after, the following week after.
Yeah, but we're not going to record us doing it.
Okay, cool.
We'll just do it as a class. And hopefully everyone comes next week. Because this ain't working out for me.
Can you go get yourself more work? Can you explain this to me and again over? Alright, prefix $500.
All right, prefix 500.
Mm-hmm.
All right, so which of the following is used to define carbon compounds with 4 C to C carbons as its longest chain? This is easy.
Wait, before I agree to say easy. Alright. I wouldn't one day because I'm going to trip by the never die. Alright, a but.
Butte, yes. Yes, it's butte. Very good.
I was going to overthink it and say act.
Why?
Why? Because we did a while ago, I realized that this and that would be different. Longest chain something.
All right, prefixes 200 or 400.
$200.
Prefixes 200. All right. I actually turned off the sound effect on this because I didn't want it to be noisy. All right, hept is the prefix used to denote carbon compounds with how many carbon bonds?
Seven.
Very good, right? Nice and sharp, nice, like it. $400 is left.
Oh gosh.
Name the
Oh,
alkyl
yeah,
group
easy.
with the condensed formula CH3, CH2, CH2. Hold on there.
Okay.
I think I didn't show the double bond. I think that's the problem. Wait, no, alkyl. No. I see. I didn't finish typing out the thing. The next one would
Yeah,
be
because it's
CH.
supposed to triple bond. It's supposed to be triple bond, not true?
No, it's an alkane. Alkyl groups are from alkanes. I forgot to
Um,
write the CH3 at the end. So CH3 is supposed to be here. Let me write it on now.
okay.
Pen CH3. So tell me what alkyl group.
You wrote on the board a while ago?
Yeah, it's gonna come up in a sec.
Okay, I just saw it come up. Methyl.
Yeah, sure, it's methyl. It has 4 carbons. Oh, I see what no, it's not wrong. And oh my God, I totally misinterpreted this question. I just made a huge blunder, I think. Okay, no, I'm fine. This is what we were doing, right?
Mm-hmm.
Yeah, it's fine. What I forgot to write onto this was that the R group would be here. So the longest chain would be on this, and this would be the branch, which is the alkyl group.
Okay. Oh, yeah, makes sense now. So this, that would make sense now. Okay. This would be propyl.
Very good, propyl.
Yeah, propyl is, yeah, propyl.
Very good. All right. So I'm going to close this right here. Take a look at that lab.
I figured how you name the alkyl stuff now. It makes sense. I see the pattern. Now.
Oh my God.
I don't feel
Should
that good now.
Should I? All right, great. All right, so I'm going to end this video here. For you guys listening on YouTube, this one was a bit longer. I'm so sorry. We couldn't finish the PowerPoint, but it's it was a bit long, I guess, and we took a lot of time on some of this, but it's fine. Again, if you want to join the classes, I'll probably break them up. If you want to join the chemistry classes, it's $6,000 Jamaican dollars a month, or $40 US a month if you're a non-Caribbean resident, non-Jamaican resident. As per my contact information, let's jump to Instagram first. If you're not following me on Instagram, go follow me on both my pages at young_genius.official or _CAM_EO. I'll follow you back on my personal page just to go over there and see what I'm up to. Yeah, and for the number is 876-501-1966, or you can shoot me an email at younggenius.educate@gmail.com. And again, going back to Instagram, that's something I'll be trying to start something very new for you guys as well. I'm trying to get volunteers to actually help out or assist with tutoring students who really can't afford extra classes. So yeah, shoot me a mail or something if you want to be a volunteer. And you guys can also follow me on Instagram to see when they'll be actually having sessions, or volunteers will be having sessions to help you guys out. So yeah, Instagram is the place to be, and following me there, and subscribe to my YouTube channel. If you're not subscribed, it's just right below this video. It's just a click, just hit that subscribe button because you know you want to, and turn on your post notifications because you want to know every time I post as well. My name is Cameo-Lee, by the way. For the end of this thing, you know that Young Genius is always committed to excellence. So come unlock your inner genius with moi. Bye guys, until next time. These outros are forever long.